Today we're going to be looking at how we take the Laplace transform of piecewise functions. Our goal is going to be able to use our Laplace transform methods in the cases where we have different forces applied on our right-hand side in our differential equation. So we'll call this discontinuous forcing. So the right-hand side is the forcing function. We're going to be thinking about situations where, for example, we might heat something up and then remove our heat source, or we might have a spring with no outside forces acting on it, and then at some point turn on an outside force. So let's take a look. We're going to start just by looking at some notation to simplify writing piecewise functions. So the first piecewise function we're going to be looking at is written as UA of t. UA of t, which is equal to 0 when t is less than a, and it's equal to 1 when t is greater than or equal to a. So the a here shows up in telling us when this switches from being 0 to being 1. Okay. So here we have a graph. Here we're equal to 0 until time 3. And then at time 3, we're equal to 1. Now, the way that we would write this is U3 of t. There's another common notation for this, which is that we say this step up happens at time 0, in which case we'll call the function with nothing written on it, u of t. Okay. Anytime you see u of t, this means u naught of t. So the switch happens at time 0. And if we're using this kind of notation, it's also common to think of just shifting this function right and left. So if we want to shift it over so that the switch happens at time a, we would just change the inside to t minus a. This function is called a Heaviside function after the mathematician and physicist who pioneered this Heaviside. It is a super apt name. We have this big transition from a value of 0. All of a sudden, we step up to this value of 1. So these guys are also called step functions. Alrighty. So let's take a look at some examples. These really simplify writing piecewise functions. So here we have the function f of t, which is u1 of t plus 2u4 of t. We're going to sketch this and then write it down using piecewise notation. Okay. All right. So u1 of t is going to be equal to 0 when t is less than 1. And it's going to be equal to 1 when t is greater than or equal to 1. And u4 of t is going to be 0 when t is less than 4. And it's going to be 1 when t is greater than or equal to 4. All right, so let's take a look at this. So we'll sketch first, and then we'll write down our overall function. So we're going to think of this in terms of like 3 chunks. We're going to think about when t is less than 1, when t is between 1 and 4, and when t is bigger than 4. All right, when t is less than 1, u1 of t is equal to 0, u4 of t is equal to 0, and so we get 0 plus 2 times 0. So our function is just going to be equal to 0. When we look between 1 and 4, well, we think u1 of t now is going to be equal to 1. right? Because we're going to satisfy that t is greater than or equal to 1. So we're going to be equal to 1. And u4 of t, well, t is still less than 4, and so that one is going to be equal to 0. So this gives us 1 plus 2 times 0. Okay, so that's overall equal to 1. And then let's add a note here. This is 1. And then when t is greater than 4, well, then the first function is still equal to 1. And the second function is now equal to 1. And so we're going to be equal to 3. Okay. All right. And so this is a picture of what this guy looks like. One thing to note is that I'm not going to be very careful about what's happening at these transition points where we're changing from one function to another. The reason for this is that we're like always going to be taking the Laplace transform of these functions. And so that means we're putting it into an integral. And the value of the integral is not going to change based off of one value of our input. So the Laplace transform will not mind whether we include whether the value of our function is equal to 0 or 1 at a. So it is not worth our energy to worry too much about that. Alrighty, let's write down our definition for this function. So in just our regular piecewise notation format. So when t is less than 1, we're going to be equal to 0. When t is between 1 and 4, we're going to be equal to 1. And when t is bigger than 4, we're going to be equal to 3. Alrighty. If someone said, like, what's f of 6? We can definitely evaluate this. This is going to be u1 of 6 plus 2 u4 of 6. And as long as this number that we're evaluating is bigger than 1, whatever this switch is, whatever the switching point is, then this the value of our function is going to be equal to 1. And so this gives us 1 plus 2. So anytime you're asked to evaluate one of these, you are just going to be plugging in your t value and then saying, is my t value bigger than this switch point? Great. Let's look at another example.